In this video, we are going to get introduced to kinematics. Kinematics is motion without a cause. Meaning we're not going to discuss how the motion starts, so what causes it, and we're not going to discuss how the object comes to a stop eventually. We're just going to deal with right after it's set in motion and right before it hits something else. We're not going to deal with the cause or of the start or stop. That will be in Unit 2. In this particular topic, we are going to focus on one dimension. So our objects will either be traveling in the X or traveling in the Y. They will not be traveling in a combination of X and Y. We will deal with that in topic 3. So when we begin discussing motion, it's going to be very important to discuss frame of reference. So typically when we set up a coordinate system, up is positive y, down is negative y, to the left is negative x, and to the right is positive x. And we have to agree on where a 0 point is. So if you use a ruler, typically we define the end of the ruler as being the 0 point, and so we would line up whatever we're trying to measure with the end, and then read off whatever mark would be here. However, you can take the same object and instead of putting it at the end, you started here and ended here. And so you're still reading off the distance between here and here, but the 0 mark is actually over here and not at this position. I always like to tell the story of one time I got an outrageous electric bill. And it turned out once I called the company, they had replaced my meter. However, the initial reading was not actually 0 on the meter. Instead, it was some number. And so they had charged me from 0 up to what my actual reading was, instead of what the initial reading was to what my current reading was. So it matters where the 0 point actually is. Is it at the 0 mark of the instrument, or is it somewhere else and you need to subtract between 2 points? We also need to discuss the difference between vector and scalar. A vector quantity has both magnitude, and magnitude is a fancy physics word for size. So I'm asking the magnitude of something, I'm asking for the size of it. So if I say, what is the magnitude of the mass, you would say 5 kilograms. If I ask you what the magnitude of the velocity is, you might say 5 meters per second. Magnitude is just asking about size. So both a vector and a scalar have magnitude. However, what makes a vector different than a scalar quantity is vector also has a direction. So the difference between the two is if you say you're going 55 miles per hour on I-95, that's a scalar quantity. You've given speed. However, if you say you're going 55 miles per hour due on 95 north, you've indicated a direction. You're traveling along 95 north. So that would make that a vector quantity. So we have to remember vectors have magnitude and direction, scalar has magnitude. And this is going to have an implication for how we do our math in this particular course. Because when something is a vector quantity, we can't mix x's and y's together, which is why in this particular topic, we're either going to be solely in the x or solely in the y. In the next topic, after we've had a little bit of practice, we'll start mixing x and y's and learn how to deal with that. Where we're really not going to mix x's and y's, we're going to learn how to deal with them separately. So in this particular topic, direction is going to be either x or y, not mixed. And most likely you're going to be dealing with positives and negatives. So you might have to deal with a positive x and a negative x, or a positive y or a negative y. So direction is going to be indicated a lot by being positive or negative.